polar coordinate system. In this system of coordinates, a point P is represented as xyz and also r theta phi. So we have a coordinate system here. We always use the right-handed coordinate system, in which the cross product of x and y is always the z. We have a point here which has coordinate x, y, z in rectangular coordinate system and r theta phi in the spherical coordinate system. So in this system of coordinate, O is the origin, r is the distance from point to origin, and this r making an angle theta with z axis is called polar angle. This is x axis, this is y axis, they all perpendicular to each other. Now if we drop a perpendicular on xy plane, and we join a line from origin to perpendicular, and then this line making the angle from x axis is called phi. Now the length of this perpendicular is equal to the z axis the length of this perpendicular is equal to the z coordinate. So here it is the z coordinate. So we see that z is equal to r cos theta, z coordinate. So we have here z is equal to r cos theta. Now if we see the situation on xy plane, this is like this. Now the length of this joining line is equal to this. We have already seen that this perpendicular is equal to z coordinate and this is r cos theta. So if we see according to this theta, this line is r sin theta, and this line as equal to this one. So this one is also r sin theta. Now if we see the situation of xy plane, we see something. And this line is r sin theta. So from here we are able to find the x and y coordinate. Now the situation here is we have an angle phi. We know that this length is r sine theta, and we have a right angle triangle where the side having both of angle is called base. This is perpendicular and this is hypotenuse. Here base is equal to x component is x, so we have x coordinate here. Base is equal to x, so we see that cos phi is equal to base upon hypotenuse, which says that cos phi is equal to base is x, hypotenuse is r sine theta, implies that x is equal to r sine theta cos phi. So we have z is equal to r cos theta. We have x in terms of spherical polar coordinate as r sine theta cos phi. Now to find y-axis, this is theta. Since these two lines are parallel and this one is intersect each other, so if this is theta, this is also this is phi, this is also phi. The both angles are same because they are two parallel lines and this line intersecting both. So here we see this triangle, we know that this is hypotenuse, this is now base, this is perpendicular, and if we want to find the perpendicular here, which is y, so perpendicular here is y, so we know that sine phi have perpendicular over hypotenuse, so sine phi is equal to y upon r sine theta. This implies that y is equal to r sine theta sine phi. So we have y is equal to r sine theta sine phi. So if we have a rectangular coordinate system which has coordinate as x, y, z, we can convert it into spherical polar coordinate. So we have the conversion as z is equal to r cos theta, x is equal to r sine theta cos phi, and y is equal to r sine theta sine phi. Now if we add them, square and add them, such as x square plus y square plus z square, we have r square sine square theta cos square phi plus r square sine square theta sine square phi plus r square cos square theta. Taking common r square sine square theta, we have cos square phi plus sine square phi plus r square cos square theta. And since this term is 1, we have taking common r square from this term and this term. This is again sine square theta plus cos square theta, so we see that this is equal to r square. So we have another relation, r square is equal to x square plus y square plus z square. If we name the equation x is equal to z is equal to r cos theta as equation 1, x is equal to r sine theta cos phi as equation 2, and y is equal to r sin theta sin phi as equation 3. So this one will become equation 4. So I write equation 1, 2, 3 here as z is equal to r cos theta, x is equal to r sin theta cos phi, y is equal to r sin theta sin phi as equation 1, equation 2 and equation 3. So we have equivalent of r from rectangular to spherical polar coordinate system. This is equation 4, and if we divide y by x, then y upon x will become r sin theta sin phi divided by r sin theta cos phi, which is equal to tan phi. So y upon x is equal to tan phi. This is equation number 5. Now if we say that x square plus y square upon z square, if we find this one, we will have why don't we write it in the new board? So here we see that if we take common, the remaining is cos square phi plus sin square phi. Here we have r square and cos square theta. This one cancels out. This one equal to 1. So we have x square plus y square plus z square equal to tan square theta. We call it equation number 6. So we have 6 equations that can convert x, y, z into r theta phi with the